Well, good afternoon. It's Saturday and welcome back to the shop. As promised, we are going to set up a car audio system today. Now, how do we do that? Well, what we need to understand is a thing called Ohm's law. Here it is here. Now, before you panic, there's not a math quiz at the end of this. But what Ohm's law says is that if I know the power, or power is equal to voltage squared divided by resistance. So with that simple formula, what we can do is we can plug in some numbers. So in my case, according to my spec sheet of my amplifier, this amplifier will produce 125 watts at 1% total harmonic distortion when it's bridged across the outputs into a 4 ohm load. So now I'm not expecting you to take this formula and plug that in. What I expect to do, and what I did, is I went on the internet and I simply found a wattage calculator. Now, wattage calculators look just like this. They have 4 fields, and those fields include current, resistance, voltage, and wattage. And with any 2 of those figures, I can calculate the other values. So in my case, I know the maximum power of my amplifier is 125 watts. I know that I'm going into a 4 ohm speaker, which means if I use my wattage calculator, it calculates that my voltage will be 22.36 volts. So what does that mean? Well, that means by simply using a voltmeter, I can turn the stereo on, turn the head unit to the volume I want, and then when I'm adjusting the gain on my amplifier, I simply take the voltmeter, put it on the output speakers of the amplifier, and increase the gain until the voltmeter reaches 22.36 volts. Because according to Ohm's law, if my voltage is 22.36 volts and I have a 4 ohm resistance, it will equal 125 watts, which means I will bring my amplifier to full volume. So that's really what we're going to do today, is we are going to simply use voltage to determine that our amplifier is running at maximum volume without going too loud. It's always easy to crank it up too much, and then you're going to get into distortion, and of course you're going to get into clipping. Now, what are the options out there? Well, the options are that you can go and buy a digital oscilloscope. Now, an oscilloscope like this is only $45 on Amazon. I would highly recommend it for 2 reasons. Number one, it has a built-in voltage, so you're going to be able to see the voltage and we'll be able to set the amplifier based on voltage. But it also shows the sine wave. It shows the signal, and you can look at the signal to determine whether or not it's distorted or clipped. Well, how do you do that? Well, you take your cell phone and you go to your favorite store and you download a tone generator. The tone generator will be able to generate different frequencies. You'll be able to send them through the system. The oscilloscope is not only going to record the voltages so that you can set the gains, but it's also going to show you what the signal looks like, which means when I'm setting up the volume on my speakers and I'm using an oscilloscope, I can drive the amplifier to the point where I create my 22.36 volts. But if my sine wave is really clean, I can actually bump it a bit. A lot of amplifiers are underrated, and they do that on purpose because they don't want to tell you it's going to be 125 watts and it ends up being 108. They would rather err on the side of too much wattage. So in fact, these amplifiers and most amplifiers you run into that are, again, high quality amps are actually able to produce more than their specifications. Now, you can't do that with a voltmeter. You got to take it to the 22.36. But with an oscilloscope, I can actually see the sine wave, and I can turn it up even a little bit more in order to drive the amplifier to its maximum until I actually see clipping in the oscilloscope, which means I'm overdriving, and then I can just back it off a little bit. So that's what we're going to do today. I'm going to show you how to do this with voltage, and then we're going to add that little bit. We're going to squeeze a little bit more out of that amplifier. And then once we squeeze a little bit more and we keep the sine wave clean, we can see the voltage. And we can use Ohm's law to then tell us the actual wattage we're getting out of the amplifier. So to start, I need to get my phone connected to my head unit, send a signal through it, and then the first thing we're going to do is come back here and measure that signal as it appears on the RCA jacks. And we're going to take a look at what does the signal look like simply coming from the head unit before it even goes into the amplifier. Let's do that. Okay, so the head unit is on. It is synced to my phone, and you can see on the phone I'm running a tone generator. That is a 1000 hertz or a 1K hertz signal going into the head unit. Now you don't hear anything, of course, because everything's disconnected in the trunk, but I do have a little bit of a trick. I have put the built-in amplifier that is inside of this system, and I've connected it to a single dash speaker. Now this is for two reasons. Number one is I can use this speaker in order to do some filling as far as volume is concerned. But the second thing is if I ever have a failure, like I blow a fuse on the main amplifier by turning it up too loud, I can always still hear my music. That is the sound of 1K hertz signal going through this system. So again, you can see I faded it out. So I'm going to fade it back out. So there we go. So I faded out the dashboard speaker. So that signal is now just going through into the trunk. Let's go check it out. Okay, so we have the oscilloscope connected to the RCA, which is coming directly from the head unit. And we're feeding that 1000 hertz signal through the system. So if we take a look over here, we can see that we're getting that 1000 hertz signal going through. Here it is here, and of course I've opened it up a bit so that we can see it better. But you can see the signal is very smooth. It doesn't have any clipping on it. And you can see that the maximum voltage is 2.56 volts. Now that is peak to peak. We have to remember that when you're setting one of these things up, if you set it for peak to peak, you're actually not going to push the amplifier to maximum. I like to use the RMS number, which is at the bottom, because that's the average wavelength, for the total wavelength output. So I'm going to be using the RMS numbers down here when I'm setting setting the gains. But like I said, you can see the maximum voltages as well. So let's just run this. And as you can see, like I said, we've got a nice 1000 hertz signal coming through and no clipping. So I know that the signal coming from my head unit is nice and clean. So the next thing we can do is we can hook it up into the equalizer, and then we're going to test the outputs over here on these settings to make sure that we have the optimal 2 volts that I like to use on the RCA, and then we can move on to the speakers. Okay, so now we've connected the clips onto the RCA jacks after they've gone through the equalizer. Now you'll notice the gains are up on the equalizer. Those are the main gains coming in. And the reason I did that, if you take a look here now, is I wanted to drive my RMS voltage on my RCAs up to almost 2 volts. You see 1.95, and that's going to move up and down. So I'm not going to bother tweaking it out anymore. The reason I do that is 2 volts is optimum when it comes to the RCA leads. So by using the equalizer on the input stage, I'm able to drive the voltages up to 2 volts, and that's where I'm going to then feed that into the amplifier. Now the other thing is that again, we're still good, because if you take a look at the wavefront or the waveform, we have a nice smooth wave. You see there's no flatness to it. So like I said, we got a nice smooth waveform coming through here. So that's key. So we've got a good clean signal. Let's hook it up to the amplifier, and then let's push the power through the amp. So the RCAs are connected back into the amplifier, which means that we're now feeding voltage directly, or we're feeding a signal into the amp. I now have my oscilloscope connected to the output of the amplifier. And what I've also done is I've added a resistor. Now, this is optional. You don't have to do this, but I find that with a resistor, you get a more accurate voltage reading. You can set this without the resistor, obviously, but like I said, I just like to emulate the amplifier and put the load on it. So we have an amp now that's running. If we take a look at the output, you can tell that obviously the amplifier is on, well, it's kind of idling away. We've now got 9 volts. And remember, we want to get to 22.36 volts, and that will then translate into 125 watts. So let's take the control. I've got the screwdriver into the gain, and let's bring it up. 10 volts, 11, 12, 13, 16, 18, 19, 20, 21, 22, 22.1, 22.56565656. There we go. We have the maximum voltage coming out of the amplifier and creating our sine wave. So that's 125 watts right now going into this resistor, and boy, is that hot. So that's why you have to get a resistor if you really want to use it. But basically, we've got this thing set up now for 125 watts coming out of my subwoofer. So let's set the other speakers. The oscilloscope and the resistor is connected to the front speakers. Now, in this case, though, I forgot to mention, I had set the tone to 60 hertz when I was setting the subwoofer. We want to actually move this up to a K hertz, 1000 hertz with, there we go, 1003. Doesn't really matter. I can bring this down to 1000. There we go. So 1000 hertz or 1K hertz. Let's start the signal. Okay, so what we've done is we've now moved the load over to the front channels, right? So we got two channels here, front and left, or front, right and left, and then of course the subwoofer is a bridge subwoofer. Now we got to make a note of something, that the amplifier, when it's running in simple 4 ohm mode, is rated at 40 watts per channel. So if we take our 40 watts per channel into a 4 ohm load and we use the same Ohm's law formula, we come up with 12.65 volts, which means at 12.65 volts, this amplifier will be at full volume. So what I'm going to do is I'm going to take my screwdriver, put it into the gain, and then we change the rate. We get a better look at the sine wave here. You can see what we've done is we've actually got a very clean sine wave. So what we can do is we can actually bump the amplifier a bit, because what we're going to do is try to get this thing to give us our full voltage, but still give us a nice clean signal. And that's kind of where we're at there now. We're at our 12.5 volts, so we're at very close to our max voltage on this thing. And we have actually a very nice signal here. And if I flatten it out, we can see that it's got a nice set of curves on it. So in all honesty, this is max voltage. Now, what I can do, and this is something if you really want to see what it looks like, I can bump it up even more. But look at that. You can see on the bottom now, it's starting to flatten. See that flat? That's clipping at 15 volts. So we're going to bring this back. I could probably get away with 13, but you know what? We calculated this at 12.65 volts. There's 12.7. So there we go. I think that's good. The amplifier is not clipping. We have a very nice sine wave. That's maximum. I think that's it. What I'm going to do is I'm going to put this all together and let's play some music. First off, I wish I could play something really great. I can't. I got to play some royalty-free stuff. So let's listen to it. So obviously that's plenty loud. I mean, that's at 30. The volume goes up to 45, so that's really, there's a lot more headroom to go. It's got a nice bass to it. I've got a good sound to it, so I'm no complaints there. But of course, I've got to do some more things on the car. So let's talk about those. Okay, so what's next? Well, what's next is to set the crossovers. Now, the way this system works is they're electronic crossovers. I can control the frequencies going to the front speakers and obviously to the subwoofer. Now, the way to do that is I have a tone generator, as you know. I'm going to set that to about 125 hertz, and I'm going to adjust the crossover on the amplifier until the front speakers start to fade away. That means, obviously, as I approach 125 hertz, the decibels drop, which will protect the front end. So I'm going to put that on the front. Now, the next thing I'm going to be able to use the tone generator for is to set up the equalizer. Now, why do I have an equalizer? Well, an equalizer does a few things. It compensates for poor speakers. It compensates for poor speaker placement, because let's face it, these speakers are way up underneath inside the kick panels. And then, of course, it also compensates just for the acoustics of the car, right? What frequencies are absorbed by what. Now, the way, again, you set up an equalizer is I use the tone generator and I generate, let's say, a 500 hertz tone, and I listen to it. Now, by sitting here, I then use the tone generator and move that to 1,000 hertz or 2,000 hertz or 4,000 hertz. And as I move through those different frequencies, the audible volume, the brightness, how loud it is, should remain the same because it's the same volume, it's just a different frequency. That's where the EQ comes in. If I listen to a 500 hertz frequency and it's a certain volume, and then I switch to 1,000 hertz, and the 1,000 hertz is a lot quieter, or maybe the 1,000 hertz is a lot louder. Either way now, I can control that through the equalizer. I can take that 1,000 hertz signal and I can compress it. I can drop it down, or I can take the 500 hertz signal and lift it up if there's a problem. And I'm going to do that for the entire spectrum of the car, going from 20 hertz to 20,000 hertz. Now, of course, these old ears probably can't hear anything above 15,000 anyways, but basically I might as well use the generator. Let's get that whole front end set up. So that's the next thing to do. Well, anyways, I hope you enjoyed the video. As I said, you can set up your amplifier by using a simple voltmeter. You just have to use Ohm's law. Don't forget about Ohm's law, and understand what the voltage is going to be at your speaker terminals and measure that voltage and turn the gain until you hit that voltage. And that way there, you know you're going to be at maximum volume for your amplifier. Now, like I said, so I hope that helped everybody in that regard. If it did, please hit that like button. What am I going to do now? You know what? I think I'm going to put on some Zeppelin. I'll see you then.